Tomorrow, any questions on tomorrow? Wear clothing that you can walk down into the canyon with and stuff. Ladies, probably the high heels leave behind. I know all of you wear them all the time.
Yeah.
Oh, I do have one question. So the packing tape that I was gonna bring, can I just leave it on the roll and they can just tear it off?
Yes,
Okay.
you'll want to tell them approximately how long of a strip to do. And if it's exact, make sure they got a scale so that they can measure the piece. Do we need scissors to cut it? Is it tough tape or?
No.
Okay. Some people can't rip tough tape, so you might want to think about that. That's again, you'll see that when you hopefully let somebody try this before you bring it in. Any other questions?
So when we assemble, are we not allowed to use anything but what they give us?
Well, I mean, I would generally think if you're gonna think of, we're trying to mimic a, is that a check?
Oh, it's mine.
We're trying to mimic what goes on in the fabricating business, right? And it's the company's really responsibility to buy tools for the person and provide them. So I would think if you need them to have a tool, you should provide it. Okay. How's that for an answer? Is that good enough? Any other thoughts or concerns?
So we have to hand in the whole packet like this to them? Or just the
No, that's due
instruction?
tomorrow, end of day. The
Okay.
packet is. What they need is everything to put it together. And we kind of discussed that a little bit yesterday. Some people might give them detailed drawings so that they can find dimensions on them. Some people might not. Some people just give the assembly drawings. I would certainly have some assembly instructions typed up to go with them, because the pictures do not tell the whole story. They can stare at it and not really know it. And it's much easier to communicate with a little bit of text on there also.
Do the assembly instructions have to be on the computer? Can they be hand drawn?
Yeah, hand drawing, that's ultimately, yes, they need to be in your report and they need to be digital.
Okay.
I don't know. We did hand drawing and hand sketching on assemblies for years. I guess if you thought they were good enough and they could follow it, I wouldn't be against it. I don't think anybody out in the industry is gonna let you do that anymore.
I was just thinking about the time factor.
Yeah, and, I mean, if you're a good sketcher, I guess, yeah, I understand what you're saying. I'll leave it up to your judgment. If you want me to look it over, I can certainly give my opinion on it at that point. Anything else?
Oh, I have one more question.
Yes.
So, one of my instructions is to use the rubber bands to make a slip knot.
Mhm.
And so I wanted to just say, if you don't know how to make a slip knot, see Appendix A. And is that something that I would have had to have drawn, or could I pull that off the internet?
You can pull it up the internet, you bet. And in fact, I've got a little sheet on how to tie knots.
Okay.
And I use it all the time because I can't remember how to do a timber hitch to save my life. And a bowling, I do a bowling like 4 times a year. I can't remember, so yeah, I've got a little sheet on it
Okay.
if you want to copy it. Slip knots I'm good at though, so I can help. I can
So
remember
you
that
get down
one.
to the end, you're like, okay, now what?
Anything else? Okay, we're going to talk about these two today then. And we're going to do this in 2 parts. First, we're going to spend probably a half hour to 40 minutes talking about the terminology, so we know all the different components of it. And then we're going to take a break, and we're going to come back and we're going to draw them. And we're going to draw the 2 major types today, both internal and external. Well, as much as time allows anyway. So we're talking about threaded fasteners. And I've got an external and an internal here. So you got both sides. Can't really see the internal due to the light, but it's there. Those are mating items. These are machines, folks. They're very highly toleranced. And they do a lot of work for us. We talked about that yesterday. We're joining, if we need maintenance, we can get great operating conditions, just like if we had a permanent fastener on there. We can get very, very good with that. We can adjust, we can even transmit power through these devices. Real high-tech machines. In fact, probably one of the 10 best inventions of all time, in my opinion. And certainly have a good time building something that's over a couple parts without using one of these. It's the next to impossible. External and internal. If I turn it sideways, you can see those in there. All right, so first let's handle the terminology. And this is on page 911. Some of this will be a little bit of a review from last semester, but I think it's worthwhile going over it, even if it is a review. A lot of this terminology also you are going to find will transmit to our next section, which is gears, which remember we talked about yesterday. Gears are threads. Okay, so you're not going, this will help you going forward if you take the time to put some of these thoughts in your mind. So in essence, I'm on page 911. And let's kind of run through some of the terms. Pitch. Page 911. Okay, pitch is right here, on here. In essence, what it is saying that pitch is the distance from the crest of one thread to the crest of the next. That's the definition in the text. And I want to expand that a little bit though. I would say that pitch is the distance from a point on one tooth to the same point on the next tooth. That's pitch. Distance from the point on one tooth to the same point on the next tooth. Now that can be edges, centers, whatever. Now the reason I want to point that out is they give this example and they give the definition based on a 60-degree included angle in the tooth. But you do have a lot of other threads, like square thread or the buttress thread, where they have flat tops on them, and you need to be measuring from the same point on one thread to the same point on the next. That's pitch. We will use that to draw. Okay, so you need to know pitch. Root diameter. It's shown right here. It is also labeled as the minor diameter. Might want to, in your text, just put right underneath it, it's also called the root. Why? Because it's the diameter at the root of the tooth. And when we say root, we're at the bottom.
The root is also the
Minor.
Minor.
Major diameter is also the crest diameter. Okay. You need these two diameters. I'm not going to say it, but I think it's fairly obvious. Why would we call it the crest diameter besides just the major? Because it's the crest of the tooth. When we draw our threads, we approximate the thread representation when we draw it. We approximate it. The major diameter is always a diameter we use, and it is approximated. Doesn't matter if you're going internal or external. If I'm doing a diameter 3/4 inch internal thread, I draw it with the major diameter at 3/4. If I'm drawing an external, I do a 3/4. Now, can they be 3/4? Not if they're going to mate, right? One's got to be larger than the other one. Okay, but we're not going to worry about that because the dimension is going to give the machinist everything they need to know, so we're going to approximate it. So the three terms you need to draw are the first three I went over. You need pitch, you need minor diameter, you need major diameter. The best place to measure these if you have to measure them physically on an item, it's tough to get to a minor diameter unless you have a thread gauge, but you can measure the major diameter up here or on the shaft and get that, and then go to a machiner's handbook for the minor. The pitch is done through a calculation. Okay, next one, TPI. It's right down here. Threads per inch. This is only used with an English thread, and it basically states how many full threads you have in 1 inch. Notice I said full. It's got to be full. You don't have partials. So if you count them up and you get 8.2, round it to 8 and go find it. Now the reason I mention that, do we have 1 inch of threads on a lot of fasteners if I'm trying to find it? Here's one right here. This thing's about a 1/2 inch long. So how do I get TPI on it? Well, I would count through a 1/2 and times it by 2, right? Or I'd count for a 1/4, times it by 4, and you can approximate it. Now, that's going to give you an approximate. Unless you have a thread gauge, you can get it exactly. But then you go to a reference document, such as the machine's handbook, and I'm going to show you a new one today, and you can get the exact specifications. So threads per inch. Now, you don't really need that to draw, but you need it to calculate pitch. So you really got to understand what TPI is, because you're going to use it to find pitch, which you use to draw. Now, as an example, why that's important for us. Here's a thread note. So, diameter 1, this is an ANSI thread note. What's the 1?
Major diameter.
Okay, yep, I asked you to look these over yesterday. Major diameter. What is the 8? It's the one we just talked about. It's TPI. Okay, now, when I got threads per inch, can I calculate pitch on that? I know there's 8 threads per inch, so 1 has to be 1/8, right? 0.125? That's TPI. So I know from here to here it's 0.125. If this is 24, and it wouldn't be a coarse thread anymore, might be an EF for extra fine, something of that nature. What's the pitch on this one? 1 divided by 24. If that was 15 threads per inch, what would my pitch be?
1/15.
Okay. 1. If this was 6 threads per inch, what would my pitch be? 1 divided by 6. 1/6. Okay. So we're always just taking that number and dividing. Now, when I do a metric thread, which we'll read, I gotta get some new pens again. Do this color. And let's do, how about a 25 by 4? This one is major diameter, right? In millimeters. The M states that it's a metric thread. The 4, what's this on a metric thread? What's that?
That's a big pitch.
It's the pitch. So it's 4 millimeters. You don't have to calculate anything. It's right in the thread note. So you now know it's 4 millimeters from one thread to the next. You kind of all get that? Okay, we good? Now, you now know enough information to draw any thread. Well, maybe not quite all of it, but most of it. So those are the real pertinent ones. Okay. Included angle. That's the angle of the tooth. Okay. Typically, these are 60 degrees. That's kind of worked out over time to be the best one. And you'll see there are some others. We talked about the Whitworth thread, which is somewhere down here. It's got the 55-degree angle. The square Acme thread. This one right here is a real popular deer thread. Okay, in fact, you're going to be drawing that in our next project. It has a different angle. It's called a pressure angle on that. It's 15, 22, 29. There's some standards on those. So, the included angle. For the most part, metric and unified national are 60 degrees, just like the Sellers thread. So we
So
represent
can you
this.
draw like if we're drawing this one for some weird reason,
Okay?
can you, without having the like minor diameter, can you still draw it if you have like a 15 angle?
Mm-hmm. Yes, you can. Because you can approximate it, right? All you have to do, if you've got pitch, you can lay out a vertical line, draw 60-degree line, 60-degree line. Where they meet is going to be the base, right?
So then what about like some of these threads are like really strange with like, or they're like shaved off at the top. Would we ever draw that?
Mm-hmm. Oh, yeah.
So where does the pitch go on there?
It's the same. We still use pitch, but remember, when we get to like the square threads that have flat tops on them, we got to make sure we understand pitches from one spot on one tooth to the same spot on the next tooth.
Oh, okay.
And we either, when we draw them, generally you use the center or an edge, something like that. Okay? And yes, we will be getting into these. You'll be drawing them by probably Wednesday or Thursday. We've got just some other quick ones while we're here. Depth of the thread, that's the difference between the major and minor, right? You can calculate this if it's not given to you. Now remember, you are dealing with diameters here though, right? Okay, what does that tell you? If I'm trying to find the depth of the thread, okay, what you're going to do is you're going to take the major diameter, subtract what?
The minor
Minor diameter. What else do you have to do?
divided by
What
2.
about you?
Yeah. Make sure you're dividing by 2 because you're drawing in a 2D arena and you want one of these, not this distance. It's both of them. It is a cylinder. Does that make sense? Is there anything, notice those same terms on an internal thread down below? Now, I've always struggled on this a little bit when they talk, and I go internal and I talk about a crest versus a minor. They just keep the same terms. Okay. So the minor is the root, major is the crest, even though when you look at the thread, because here's the body of the object here, right? Okay, so in essence, that's really the two. You think, oh, the crest is out here, it's now the minor. No, we just keep the same terminology, okay?
I'm sorry, will you go over that again?
Yeah, okay, so we talked about minor and major, root and crest, being kind of synonymous with each other. Well, when you come to an internal thread, here's really the body of the tooth right here. Is that guy. So the crest of it is here, right? Which is equal to what? And
The
this is
minor.
probably confusing the issue.
Yeah.
So don't
Crest
go
is
by
the
what
major.
it says?
It's, just go minor and major. Okay, minor diameter will now be the crest of the tooth, major will be the root of
Oh,
Well, I mean,
okay.
if you take the hatchet off, it's
Yeah,
the exact same thing,
yeah.
the
right?
tooth. Yeah, it's the same tooth, it's
Even
the
though
same
it's
tooth, but it's inverted. right? This one, the body's here, tooth is away. Here, the body's here, tooth is away.
Mm-hmm.
Notice they put the terms on them here. They're saying, use the same terms from tooth to tooth. Minor diameter is always the root, major is always the crest. All right, one more term, and we need to turn the page, go to page 912. The lead. The lead is the slope of the tooth. Lead is the slope of the tooth. Okay, so in essence, if we had a straight line, how do I measure the slope of that tooth? Okay, and we do it with a term called lead. So you have a single lead, and in essence, another definition for lead is the distance or the number of turns traveled in let me say this again, number of threads traveled in one 360-degree turn. So if I have a single thread, which most threads are singles that we use in day-to-day stuff, I turn that one time, it moves one thread. Right? If I got a nut and I'm turning it on there, I turn it one 360-degree turn, it moves one thread. That's what lead means. We do have other things. We have double, triple, even quadruples. Where if I've got a double thread, I do one 360-degree turn, it goes two threads. You ever wondered how a NASCAR tire gets off and on so quick? I have.
Yeah.
In fact, I watched a little bit of Formula One racing there, doing one of those Grand Prix. These guys would pull in, by the time they stop, they're leaving in 3.5 seconds and they've got 4 new tires on. It's just amazing. You know, and I've never seen one, but I envision that the lug nuts on those things are probably 4 or 5, those slant on them. If they turn them one time, boom, they're already all the way off. Okay. It's the distance it travels, so it's the slope of the tooth. I've got some examples of those too that we'll look at later. This one right here is a double thread, and I've got a ton of singles in the deal right there. All right, so that's lead, slope of the tooth. For a couple of these other terms, let's go to page 913. And let's just make sure we understand. We've seen these before, you were asked to look at them. I just want to hit a couple things. The very last one, where it says B here. That will only be an A or a B. What does an A and a B mean? Right? Yeah. So if I'm pointing to an external thread fastener, I must use an A. I don't know why they do this. You would think the picture is kind of self-explanatory, but maybe if we're doing, I don't know, a section assembly where I've got an internal and an external thread, maybe that's why they've done it. I'm not really sure. Internal thread is a B. Now, most threads are right-handed. It means they turn on righty-tighty, right? Lefty-loosey. We've all heard those terms. Do you see an RH on here for right-hand thread? We leave it off if it's a standard right-hand thread because it's assumed. If we go left, so it's a left-handed thread, which means it works just the opposite. I turn it to the left to pull it off. So in this case, it'd be lefty-tighty, righty-loosey. Where do we use left-hand threads, by the way? Anybody know? How many of you got a gas barbecuer with that propane bottle on? You don't, Missy?
Mm-mm.
Okay.
Where's charcoal?
All explosive gases use a left-handed thread. So propane tanks, natural gas, all of these, we use left-handed threads. And so when somebody's just sitting at a fixture, they can't see the source, they turn it left and they know, hey, this has got to be a gas line.
Wouldn't that be
So
more
better not be
dangerous?
smoking around this thing. What's that?
Wouldn't that be more dangerous? For people that don't know and just leave it on because they think it's all the way off or something?
Yeah, well, there are a couple indicators. If you're dealing with brass fittings and it's a left-handed thread. Why do we use brass? Can't spark it, right? Metal, you can whack it with a metal wrench and it'll spark. Brass won't. And that's why they use all those brass fittings on power gas systems too. But be that as it may, all we have to do on a left-handed thread is we include an LH at the end. Now, if you're doing the slope of the thread, the slope will change. It'll go the other way. So, like this one's a right-handed, right? Slope's going right. If the slope was going left, it would be a left-handed thread. But you draw them identical, just mirror image. Any questions so far? Okay. This one shows it, so I'll just go right here. Chamfered edge. This chamfered edge right here. It's typically 45 degrees. And it is done as a standard on what we call a cab screw.